So how does atorvastatin help lower cholesterol? Because our liver produces most of the cholesterol that we need, atorvastatin helps lower cholesterol by limiting the amount of cholesterol produced by our liver. To illustrate the mechanism of action of atorvastatin, let's first look at how our liver produces cholesterol. The cholesterol synthesis pathway is very complex and involves several steps. Yeah, yikes. Let's first simplify this pathway into its core phases. Much better. The most important step in the cholesterol synthesis pathway, with regards to the rate that cholesterol is created, is the formation of mevalonate from HMG-CoA. The reason that this is the most important step is because it is the rate-limiting step of the pathway. What this ultimately means is that the overall rate of production of cholesterol ultimately depends on the rate of this step. To help illustrate this point, let's imagine the entire cholesterol synthesis pathway as an hourglass. The rate that the hourglass flows from one end to the other depends on the speed at which it flows at the bottleneck and slowest part of the hourglass. In this analogy, the bottleneck and slowest part of the hourglass is this rate-limiting step of the formation of mevalonate from HMG-CoA. Now let's take a closer look at this rate-limiting step. This reaction is driven by an enzyme known as HMG-CoA reductase. The enzyme acts as the fuel that gets the reaction going. In this reaction, HMG-CoA enters the enzyme at what is known as the active site of the enzyme. Here, the enzyme essentially cuts the coenzyme A from the HMG-CoA to form the mevalonate. Without this enzyme HMG-CoA reductase, the cutting process is severely hindered, and thus the rate at which HMG-CoA is converted to mevalonate is significantly slowed down, which then in turn slows down the production of cholesterol. This is where atorvastatin comes in. Atorvastatin acts on the liver as the primary site of action and is a competitive inhibitor of the HMG-CoA. To understand what this means, let's look at the structure of atorvastatin and HMG-CoA side by side. We notice a similar structure for both the atorvastatin and HMG-CoA circled here. Conveniently, this is the structure that binds to the active site of the enzyme. It's almost like it was designed that way. Thus, when looking at atorvastatin versus HMG-CoA and its mechanism of action, atorvastatin will occupy the pockets of the enzymes. This then blocks the HMG-CoA from being able to enter the enzyme and receive the cutting of the CoA to form the mevalonate. By decreasing the amount of available HMG-CoA reductase, we then limit the rate of reaction of HMG-CoA to the mevalonate, reducing the production of mevalonate and ultimately reducing the production of cholesterol, thus lowering blood cholesterol levels. In addition, by reducing the concentration of cholesterol in the body and in the liver cells will compensate by increasing the activity of receptors for low-density lipoproteins, or LDLs, which remember are traditionally known as bad cholesterol. Thus, liver cells will take in more LDL from the bloodstream, reducing the amount of LDL in the bloodstream. Thus, with the action of atorvastatin by blocking the HMG-CoA reductase, thus reducing the production of mevalonate from HMG-CoA, thus reducing the production of cholesterol and increasing the intake of LDLs in the bloodstream by liver cells, these all work to help lower the overall cholesterol in our body.